Hi and welcome to the course of information security. Previous video we saw about the IDS. Now we will see the various category of IDS: host based intrusion detection system, network based intrusion detection systems, and other parameters to prepare an IDS. So here we also seen some technical details and the various category of IDS and how we can deal with them, and we also see how to make a strong IDS system. Now the basic principle of intrusion detection system is to prevent the network, prevent the system. So it basically provides a service which will identify the intrusion. If intrusion is detected, so it should detect quickly enough, because if delayed in detection, that means you can lose so many things. So it should detect the intrusion as fast as possible, so the intruder can be identified and ejected from the system before any damage is done or any data are compromised. Even if the detection is not sufficient timely to preempt the intruders, the sooner that the intrusion is detected, the less the amount of damage and the more quickly that recovery can be achieved. That means as soon as possible you figure out it, that much is beneficial for you. An effective IDS can serve as a deterrent, thus the acting to prevent intrusion. Okay, the intrusion system is good enough if it is stopping all the malicious activity, malicious traffic. It is a path breaker for the malicious activity, the attackers, then it is a good one. Intrusion detection, the collection of information about the intrusion techniques that can be used, strengthen the intrusion prevention measure. Basically, if we talk about in general terms how we know the behavior of the intruders or the behavior of the authorized person, so there is a kind of overlapping in between. If you see in the diagram, basically the intruders are looking for the profile or the things where they can achieve something profitable. They are doing the things continuously, and the authorized people perform the things role those are available for them. But if we talk about in terms of finance, so in a financial terms, the both profile visit the financial things and perform the things, but you can verify with the role, with their role. Okay, so that is a clear-cut differentiation between, but definitely there are some overlap reason in between the intruders and the normal authorized user, and that is a challenging task in this development, IDS development, because we have to figure out the reason, the shared reason, how we discriminate the authentic user and the intruders. So that is the most important task that whenever we realize, so we have to be perform the algorithms very much effectively. So there are various analysis approaches for the same thing. Basically, two most common approaches are the anomaly detection and the signature or heuristic detection. Mostly anomaly detection works with the Linux operating system, where you have a traces of system calls, and signature or heuristic detection things will work with the antivirus system, Windows operating system, and so on. So these two common terms for the two different behavior, two different type of style, but they both are working well. If you have a combination of both the things, that is more best and more secure. Basically, if you want to secure the information from the source side, you have to use hits. If you want to secure the information throughout the network traffic, you have to go with the nits. Okay. So if we talk about the anomaly detection, that is basically purely ML based techniques are coming here, and we already did the same thing into the lab also. In the beginning, we have a data, that means the captured data that we captured with us. Okay, and we will divide the data in two different parts, one is the training phase and testing phase. That is a machine learning approach for the detection or the creation of IDS. So we'll train our model, and set the threshold values, and whenever we test, we predict the data and try to reconstruct some reverse feedback things are happening. We'll figure out the anomaly result, we'll observe the result, and if the things are good, then you can say our model is good, and we can build a improved IDS system. So anomaly detection is basically performed in a various ways. Where in anomaly detection, you can go with the statistical method. The statistical method, that means we are observing the behavior of univariate, multivariate, time series model and the various things. That means on the ground of mathematics, we can analyze the result and figure out what thing is happening, the probability with uh, the probability and the other things. The knowledge base is a basically approach that use the expert system. Okay, so expert system will classify the behavior, create the new rules, and see according to the set of rule where your input is fit, whether it's benign, it's a malicious. Okay, and the machine learning approach, as we know, we have a data and we'll go with some machine learning approaches. So table classification we are going to perform, maybe it's the log regression, it's a classification, whatever is possible, we can do that thing. On the other side, if we talk about the signature or heuristic based method, so it uses basically a known malicious data pattern they have. They know the attackers rule, how the attackers were performing, and it also known the misuse detection. So they are following various approaches in that. That means we know the pattern of attacker, and we will verify that pattern in a go through. We will try to identify whenever data is coming. Okay, so that is the signature based heuristic detection. Now that after that the thing is coming, the analysis approach is okay, but which approach we have to be using what pattern? We have two different patterns. One is the host based intrusion detection, and another is the network based NITs, hits and NITs. Hits basically add the specialized layer of security software to vulnerable or sensitive system. It is basically used to prevent our data, individual data like servers. Basically, this scheme will work with the servers. Okay, so in a server, basically the server machine, you can go with the like the Linux server, and the server you can figure out the system called traces, audit log file. So there are some common data source in a head system where we can figure out the traces. System call trace, that means the record of a sequence of a system call by processes on the system. It is widely acknowledged as the preferred data source for hits. Audit log file is another way. That means most of the modern operating system basically include the accounting software, and they collect the information on the go, okay, on the fly, and some VM also tracing the log files. So, but file should be available with the root privilege. And the advantage of this one is that you have all the information what is happening in the system, whether background or front end, and you can verify it whether the performer or the correct one or not. So it is good way and easiest way to audit the things and figure out the vulnerability or the malicious activity. File integrity checksum is another method. That means if you have some important file, some file related to the finance, you can perform the integrity check over there through various algorithms like the checksumming, hashing. There are several approaches that help you to figure out the integrity. But the only disadvantage, you have to be perform additional tasks. It increases the overhead of the system. Another one is a registry access. So the registry access is a most common and oldest method used by Windows system. They have a registry of all the deployed software, and every information related to the software is stored in that registry. So as a team of security person, team of forensic person, we can figure out that registry entry and see what is happening in the system. If we talk about the approaches that we use in a hits or how the hits work. So hits have various approaches like the anomaly. So anomaly things will be useful in a Linux operating system, as I told you earlier, because it's a host-based intrusion detection system. If you are running a server with a Linux operating system, then this approach is very well. You can trace all the system calls, okay, and you can figure out. In a Windows, you can verify the DLS and executables file. That is also fine. Another approach is signature based. Signature based is widely used in a Windows machine, Windows kind of machine, and the antivirus systems also using this thing for to prevent anti-malware softwares products. Okay, so these are very commonly used in a client machine or the machine in a corporate. This web application proxies and firewall everywhere. This is a very common approach because most of the attacks, whenever we identify, we know the pattern signature. So that is the quickest way to prevent the machine. Another approach is a distributed hits. Distributed hits, that means we have a distributed culture or there are more machines which are working in that area. Okay, if you see in the diagram, there is a various machines are connected with the device and the hits are working in various kind of systems. In a traditionally, what happened? We have a single machine, the host-based IDS, which will force on a single system standalone operation. But in a now these days, things are working distributed manner, distributed collection of hosts supported by LAN or internet work. So although it is possible to mount a defense by using standalone IDS to on each host, but we have to perform additional work over there. But if you want to perform more effective defense, then all the systems should be connected and they should be coordinated with each other. So that will give more flexibility and security. That things come under the distributed IDS hits. Distributed IDS may need to deal with a different census data format in a heterogeneous environment. Maybe one machine have a Windows, one machine have a Ubuntu machine and something else. Because we have a different system with different sensors. And one or more node in the network will serve as a collection and analysis point for the data from system on the network. Definitely we have to modify and verify the collected data. So we create a collection point and analysis point. So the raw sensor data or the summary of data must be transmitted across the network. Therefore, there is a requirement to assure the integrity and confidentiality of these data. Integrity is required to prevent an intruder from masking his or her activities by altering the transmitted audit information. And confidentiality is required because the transmitted audit information could be valuable. Okay, so either centralization or distributed decentralization architecture can be used. Okay, with centralized architecture, you have to collect all the things into the central place. And decentralization, that means each node is behaving like a server and they have some different computation capabilities and they will perform the things. The very good example that I heard that for distributed IDS is about the University of California. They deployed a distributed environment with various approaches. Okay, they have host agent module, which will audit the collection of the all information and perform the background processing monitoring system. Another is a LAN monitoring agent module, which operates in the same fashion as a host agent. If you see in the diagram, there are LAN monitor is there. Okay, so it analyzes the LAN traffic. Host agent module is deployed in various machines. If you see the host is written there. Then the central manager module. The central manager module receive report from LAN monitor and host agent and process correlate these reports to detect intrusion. These three modules works and they will deploy in a centralized distributed system. So that is the thing that happening in the hits. Now we talk about the NITS, network intrusion detection system. So hits is working for an individual system, that is sure, and the network system is also works for the LAN network. It will prevent the whole network. So we need a common choke point where the external and internal networks are matched, and we put our NITs over there. So it will stop all malicious activity for entire network. Okay, so NITs will basically monitor the traffic at selected point on a network or interconnected set of networks. NITs examine the traffic packet by packet in real time or close to real time to attempt to detect intrusion pattern. The NITs may examine network, transport, or the application level protocol activity. Okay, so both, if you merge both of the things in the same group or same pattern, that is more beneficial for us. It will prevent the system. NITs typically includes the perimeter security infrastructure of an organization, either incorporated in or associated with the firewall, because the basic objective idea is to strengthen the firewall. They typically focus on monitoring for external intrusion attempts by analyzing both traffic packets and traffic contents for malicious activity. With the increasing use of encryption through NITs have lost access to significant content, hindering their ability to function well. A typical NITs, that means the network intrusion system, facility includes a number of sensors to monitor packet traffic, one or more server for NITs management function, and one or more management console for human interface. Understood? There are several things happen in that. If you think logically, you will figure out all the things automatically. This thing, if you want to prevent the network, what you require, what things is important. The importance is that we are sitting into the place where all packets are coming, so we can see the packets and block them. We will prevent the human interface. We will analyze the traffic pattern to detect intrusion, may be done at sensor, the management server, or some combination of these tools. If you talk about the network sensors, those used in a NITs, so basically the sensors are doing nothing. They are passively monitor the things. There are inline sensors. Those are inserted into the network segment. So the traffic that is passing from it, they will monitor, and they are doing in a normally passive mode. So passive mode sensor copy the network traffic, and they never touch the real traffic. They will pass the traffic, and later on we will analyze. So that will help to figure out. Both things will work in the network NITs, but we place a sensor in a proper place, so we'll figure out. So how the network NIT sensor deployment happening? So the common location for the network intrusion detection system sensors is just the external firewall, from where the all packets are coming. So the external firewall place, that means we can see the attacks originating from the outside world. Okay, that is where we have a LAN switch fiber or the network. We can place it somewhere. So we can penetrate the network perimeter defense. Highlights a problem with the network firewall policy or performance. So we can also measure the or review the policies of firewall. See attacks that might target the web server or FTP. Even if the incoming attack is not recognized by the IDS, can sometimes recognize the ongoing traffic that result from the compromised server. If you are not identifying the attack, your server should be compromised. So the placement of network sensor is most important. We have internal servers, internal systems which will manage the LAN. Definitely it is connected with the LAN switch. LAN switch have connected with the internal firewall. So firewall is just a set of rules, allow or not allow. So this thing should connect with the LAN switch or router. So how many internal firewalls you have, you all are connected with it. So we can put our IDS system here in this place where the external firewall is connected. So we'll see the traffic and build the rule again and strengthen the system. So the simplest thing is that instead of placing NID sensor inside the external firewall, it should be placed between the external firewall and the internal or WAN. That means in between that. So we will identify the things. Okay. So if you know the exact placement of that, that means you collected several data. How you can process with that data? So we need a technique how we detect the intrusion detection technique. So with the host-based intrusion detection technique or network-based intrusion detection technique, whatever we are using, we use the signature-based detection as well as the anomaly detection. So what happening in each of the case? So first we discuss about the signature detection, and we also discuss some other techniques also. So the signature-based detection, very first we can and we have a list of pattern and signature. So the very first case is the application layer reconciseness and attacks. Most network-based IDS technologies analyze several applications protocol like the FTP, HTTP, IMAP, IRC, NFC, NFS, post office protocol, SAPE, and so many. Whatever is coming into the application, SMTP, SNMP, they all are monitored by this IDS system. Okay, so the NITS is looking for attack pattern, and they have been identified the targeting these protocols. For example, of attack is in cloud buffer overflow, password guessing, malware transmission. These type of attack they will identify through the application layer reconciseness. If we talk about the transport layer reconciliation attack, so NITS will analyze the TCP and UDP packets, definitely the transport layer packets, and try to see whether packet is having unusual fragmentation or it has some vulnerability or some specific attacks such as SYN flooding, etc. If we talk about the network layer perspective, so it will see the IP packets and some protocol like the ICMP, IGMP. They are verifying and trying to see whether the packets coming in the correct gateway, correct route. They also we figure out the IP illegal IP headers. If you're talking about the unexpected application service, so NITS attempts to determine if the activity of a transport communication is consistent with the expected application protocol. That is fine. Otherwise, it is an unexpected application service. Policy violation you can also monitor with the help of signature detection, because each and every website and packet have a kind of policy and rule. So if the system is not following that rule or policy, the port number is not correct, that means they are violating the things. Another intrusion detection technique is an anomaly based detection technique. It will basically most useful or most effective for the DOS kind of attack, denial of service. That means suddenly increase the traffic or the packet transmission in a particular network, which will lead the DOS attack. Scanning, some packets are coming into the device and perform the scanning kind of thing. Basically, the network layer or the unexpected applications are doing that thing. ICMP is mostly used in that. Worms is also the things. Worms is spreading through the network and they're increasing their account. So that type of thing we can figure out through the anomaly, because these are definitely making an anomaly in a system. Other than this, we have two other methods like the stateful protocol analysis. The stateful protocol analysis is a subset of anomaly detection, basically we can say, that compare the observed network traffic against a predetermined universal result. So this is slightly distinguished from the anomaly technique, because SP understand that tracks network transport and application protocol states to ensure the progress are expected. But it required the high resource. So this is not very much common, but it have a predetermined set of state. And normally we'll match with the rule, but we are not biasing something, but it is we're not predicting something. But here we are predicting, okay, this thing should be like this one. The slight difference may lead to the intrusion detection. Another category is a logging of alert. That means when a sensor detects a potential violation, it sends an alert and log information related to the event. And the NIDS analyze module, and it will use this information to refine IDS parameters and algorithm. The security administrator can use this information to design prevention techniques. Typical information logged by the NID sensor includes various things like the timestamp, things are written over here, connection or the station IDs, event or alert type, rating, network, transport, application layer protocol, source destination IP address, source destination packet, ports, number of bytes, decoded payload data such as, so various things are here. You can build your own data set with these type of information and try to figure out whether the packet is doing well or network is doing well or not. Now, another key thing is that the distributed or hybrid intrusion detection system. If we merge both the technology anomaly and the previous one, the signature based, that will become a hybrid and distributed also. And distributed, there is one advantage that the resource are shared with among all the network. So we work with the less resource and the computation will be increased. So we'll get the effective result immediately. Basically, this network have various kind of system. If you see, there are platform policies, collaboration policies, policy enforcement point written as PEP. DDI is a distributed detection and interference. Okay, so they all are connected with the adaptive feedback based policy. All things go to the machine, and machine will figure out the things. Okay, so we can say this approach is basically effective to determine the intrusions and strengthen the firewall. If machine have a sufficient number of traces and the log file, the analysis should be easy. So because if it see the intrusion detection system, it collect the data, process the data. So IDS deployed selectively may miss a network-based attack or may be slow to recognize that an attack is underway. So the use of multiple IDS that share information has been shown to provide greater coverage and more rapid response to attack. That is a basic advantage of this approach. We are running several IDSs on the shared, they are all shared. So it is a chance we can catch all the attacks. Analysis of network traffic at the host level provide an environment in which there is much less network traffic than found at a network device, such as the router. The attack pattern will stand out more, providing an effective and higher signal to noise ratio. Host-based detection can make the use of richer set of data, possibly using application data from the host end as input into the local classifier. So the distributed or the hybrid IDS can be constructed using multiple products from a single vendor or from the different vendors. So there are several things connected with it. And if we know the IDS how works, so there's a, if we want to understand the working of the IDS, so there is a very effective case study of Snort. Snort is a kind of IDS which is open source. Okay, So Snort installation consists of 4 logical components. We will discuss each one. Okay, so Snort is basically an open source, highly configurable and portable host-based or network-based IDS. Snort is referred to as an lightweighted IDS, which has various features like easily deployed, efficient operation that uses small amount of memory and processor time, easily configured by the system administrator who need to implement specific security in a Snort amount of time. So Snort architecture basically contains 4 logical components. Okay, and it is easy to available. You can also install it. The very first component is a packet decoder. The packet decoder processes each captured packet to identify and isolate protocol header. Basically, it will collect the packets and decode that packet and try to capture or the header of the packet, header of the data link, network, transport, and the application layer. The decoder is designed to be as efficient as possible, and its primary work consists of setting pointers so that the various protocol header can be easily extracted. So the job is that to extract the headers. Then after we have a detection engine. So detection engine does the actual work. Okay, once you have a packet, you can decode it, then send it to detection engine. Detection engine does like that. The module analyze each packet based on a set of rules defined for this configuration of Snort by the security administrator. Basically, in a sense, each packet is checked against all the rules to determine if the packet matches the characteristics defined by rule. The first rule that matches the decoded packet trigger the action specified by the rule. That means whatever written in the rule, it will perform. It will verify all the things with the rule. If no rule is matching, then definitely packet is discarded. That means it will allows only the valid packets. So if your packet is having some anomaly or something unauthorized, definitely it is going to be discarded. If it follows the norms, each and everything, then it will allows by the system. Another component is a logger. So for each packet that matches the rule, the system will log that file. And whenever logger option, it will go with the logger option or log the files. So we will store the detected packet in a human readable format. So later on it is used for the analysis. And the fourth module is an alerter. If something is not really good or not happening in a well manner, so for each detected packet, an alert can be sent. The alert option in the matching rule determine what information is included in the event notification, and this will be used as the Unix socket or some socket programming to send to the administrator. Okay, so Snort system is very much simple. It follows some patterns and rules. Snort rules is look like the given diagram. Okay, where we have action, protocol, source IP, source port, direction, destination IP, destination port are there, and each rule is contain a fixed header and the 0 and more options. The rule header having the option keyword, option argument, and so on. If we are talking about the action part, so in action part we can generate the alert, we can log the file, we can pass or ignore the packet, activate the another rule, we can deactivate the rules, drop the IP table, drop the rules from the IP table, we can reject the packet. So there are several things that we can perform. These things are known as an action. Okay, so the action is happening in that, and these are the very simplest thing. Other than this, we have a 2-3 more variety of the IDS, just like the knowledge base IDS. So knowledge base IDS, or we can say the signature base IDS. Basically, it uses the database of previous attack profile and some known system vulnerability to identify the active intrusion attempts. Knowledge base IDS is currently more common than the behavior based ID. Behavior means the statistical. If you have a statistical base ID, So knowledge base is better because we have a set of rules, set of pattern that we already known or captured. We'll store in a database and try to figure out. The advantage of this thing is that advantage of knowledge base is that it has lower false alarm because we know the things correctly, and the alarm more standardized and more easily understood by the behavior based ideas. Disadvantage is that signature database must be continuously updated and maintained, because if you have a very much older database, you don't know about the newer attack and your system may be compromised. So new unique or original attacks may not be detected or may be improperly classified because we don't have the pattern of previous record. And another category is a signature based ideas, or we can say the behavior based ideas. So behavior based ideas, which is the anomaly detection through the statics. That is the older techniques, old school technique, and it is a baseline of the starting or the learning process. It will identify through the patterns, through the known pattern. The advantage of that, it will dynamically adopt the new, unique, and original attacks, because if some pattern is coming, it will learn very quickly and less dependent on identifying the operating system vulnerability. The disadvantage is that it has a higher false alarm, because if new attack is coming, if you don't have any pattern, maybe it will not giving the correct value. And it uses the pattern that may change often and may not be static enough to implement effective behavior-based ideas. And the last category is a machine learning-based ideas that we are dealing in a labs. We have a data set, we see how the machine learning works with the ideas. So that's it. That's all about the ideas.